Let's say you've got two groups of people and each person has given a rating on something, and you want to compare whether one group's rating is on average greater or less than the other group's rating. So you could this situation here where you're comparing two groups happens all the time. This could be, for example, let's say you work for a politician and your politician wants to raise money. So they're sending an email out to hundreds of thousands of people, but they've got a couple of versions of that email they want to test out with just a few people first to see which one works better. Or another situation would be people going to a website and there's two different versions of the website, and you want to see maybe how long people spend on average on the two versions of the website. So you've got version A, version B. You give version A to one group and version B to another group. Another example might be a company has created two versions of a new company, right? They're creating a logo, and they create two versions of that logo, version A and version B. So they show one group version A, one group version B, and they compare the group scores. Presumably, if you want to compare these group scores, you would sort of like randomly decide which person grows into which group. So how would you test whether these such ratings between two groups are statistically different from one another? You could say you could just compute the average. You could say the average for group A is such and such, and the average for group B is such and such. Why don't we go ahead and do that? So let's calculate the average for group A over here. So here's group A, and here's group B. And you can think of each one of these numbers representing one person's rating on the version of the logo that they saw. Group A saw version A of the logo, Group B saw version B of the logo. So let's compute A's average. So we're going to use a formula here. This cell is going to equal average. Let's see here. We're going to use the function that gives us average, and we will highlight that column there, and we will put dollar signs in front of the letters, in front of just the numbers rather, to make that a constant. So that way it's constantly staying between rows 2 and 11. I click enter and can drag this down, and I should say 48 the whole time, right? Okay, so the average is 48 for the whole group. We really only needed to do that once. We didn't need to drag that down, but you'll see later why I did it that way. All right, now we want group B's average. That's 65.4. We can drag that down. Again, so we've got 48 and 65.4. So we know that on average, group B rated their logo quite a bit higher than group A. So how would we tell whether that difference, 65.4 minus 48, how do we tell whether that difference is actually due to chance alone, or is it something real? And there's a method for calculating the likelihood that that score was derived by chance alone. And so that's what this video is about. So we have to take into account this difference between the average for group A and the average for group B, but we also need to take into account the fact that there are differences within each group. So, right, you can see that not everybody marked the same score in group B, and not everybody marked the same score in group A. We call this variation within the group. There's variation between the groups, looking at the average for group A and the difference between that and the average for group B, and there's variation within the groups. You can see just looking at the column here. So how do we start to think about this within group variation? The between group variation we can represent just by taking one average and subtracting it from the other average. But we've got all these scores within groups, and so how can we numerically represent this variation within the group? So there's a few steps involved. Let's go ahead and do those steps. So the first thing you do is calculate something called the deviations. So let's do that. The deviations, it's pretty simple. It is you will take a person's score or rating, and from it subtract the average for that group, and you will end up with a set. If you do that, you will end up with a set of positive and negative numbers here. So this is each person in group A, it's their deviation score. And the deviation score represents how far away from the average within their group they are. So if you have a very high score above average, it'll be a positive number. If you have a very low score below average, it'll be a negative number. And if I added all of these up, it would equal to 0 because I'm adding positive and negative numbers. So we do the same thing for group B. We take a person's score in group B, and from that we subtract the average for group B. And same story here. We should get a set of positive numbers that add up to 0. And we can actually see that here. If I add all these up, boom, it's 0. Same for this column. Whoops. Look, that's interesting that it's not quite 0. This shows you something about Microsoft Excel. It's that there is rounding error. So it's actually rounding the values in some of these cells. And we get this value here, which is, right, so close to 0 that it doesn't matter. In any case, I will clear that out. Now, what do we do when we want to be able to represent the variation within a group using just a single number? So so you can't just add all of these scores up, because then you end up with 0, which is useless. It doesn't tell us very much information. So the statistics, the founders of statistics decided that one way to deal with that is to square each number. Now, yes, you could simply take the absolute value of that number, and there are other less common methods where people do that, but just because of historical reasons, the method for doing it is by squaring each number. So we would simply take 46, and I'm going to do a caret 2, and that's going to square that number for me. So then, a negative number times a negative number is a positive number, so we're ending up with all positive numbers here. That's your deviation squared. And then we need to do that for group B, so I can drag that over, and that should be, yep. Do the same thing. Oh, check this out. If you read the reading, you would know this already, but just in case you didn't, if I go to this little corner here and double click, that's going to go all the way down the columns for me. Okay, so we've computed the deviations squared. And so there's another step. There's a few more steps, so bear with me. Now we're going to compute something called the sum of squares for each group. Group A, sum of squares, and group B, sum of squares, right? And sum of squares is exactly what it sounds like. It is the sum of all of those numbers squared. And same thing for group B. Just make sure that highlighted properly. Yes. Okay, so now we have the sum of squares for group A, the sum of squares for group B, and now we are going to compute the variance for each group, which is a pretty useful term. So how do we compute the variance? Well, what we do is we take the sum of squares number, and we divide that number by however many people are in that group minus 1. No, that sounds weird, but look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people in this group here, and 10 people in both groups actually. So 10 minus 1 equals 9. So we're going to divide that by 9. I know it seems weird, and I will give an explanation video in the future as to why it's not 10 instead of, or excuse me, why it is 9 instead of 10. But for now, just trust me that this is the step, that we're going to do it this way, and that in the long run it ends up being better doing it this way. So we have the variance for group A, and we have, if we drag that over, I believe we will get the variance for group B. Correct. Now, just briefly, that is, the variance is a useful term. It's used in computing a lot of different statistics. There's also something called the standard deviation, and we don't actually need to compute this for the sake of the t-test, but I'm going to compute it really quickly here. The standard deviation is simply the square root of the variance. Excuse me, didn't do that right. Square root of the variance. So we can say the standard deviation for group A is 36.26, and the standard deviation for group B is 23.57. So for now, I just want you to remember, computationally speaking, that's how you get the standard deviation. And you can think of it as sort of, going back to this column here, the deviations, you can think of the standard deviation as sort of like the average deviation from the mean. We can actually check our work here. Let's check our work. Excel actually has a square root function, or excuse me, a standard deviation function. So we go to standard deviation for group A, see what that tells us. 36.26, and we've got 36.26 here, we've got 36.26 here. If we drag that over to get the standard deviation of group B, it's 23.57. And over here, it looks like we've got 23.57, so our math turned out correct. All right. So we've got this variation now. Again, that standard deviation thing is just something I wanted to show you for now. It's not actually involved in the computation of the t-test. I'll show you why that standard deviation is important in an upcoming video. The variation here, or the variation in the t-test term is going to be represented slightly differently. Interestingly, there is this way that this t-test is going to pull the within group variation. So it's called the pooled within group variation, because we've got within group variation for group A, we've got within group variation for group B, and we have to account for both of those. So we need to put both of them into a single term somehow. So the way to do that, computationally speaking, is you take the variance and divide it by the actual number of people in the study, or in the group rather. So we take, this is going to equal the variance of A divided by 10, because there's 10 people in that group. And same thing for the B term. And then we will take the A term plus the B term, add those together. And for the sake of the t-test, that's how we're going to represent our within group variation. There's one more step though, and that step is to take the square root of that number. So that's going to end up being at the bottom of a fraction, so it'll be the denominator of a fraction. So we simply take the square root of that number, and we have the number that's going to be on the bottom of our fraction, and that's our within group variation. That is our single number that represents how much within group variation is going on here in this two group t-test. And then we need to know the within group variation, and as I mentioned in the beginning, that within group variation, or excuse me, that between group variation is represented by just taking one of the means and subtracting the other mean from it. So that's our numerator, negative 17.4, denominator 13.677, etc. It doesn't matter. Notice that this is a negative number. If I had taken group B minus group A, it would be a positive number. For the sake of the mathematics, it doesn't really matter which one I put first. It just means I need to keep track of which one I put first so I know the direction. That's something we call the direction, which group is higher which group is lower, then that's going to give you a negative or positive. If your statistic is negative or positive, that indicates the direction of your statistic. Okay, so t ends up equaling the numerator over the denominator. So we've got a t statistic of negative 1.272, etc. I told you at the beginning of the video that this was all about computing the likelihood that that between group difference was due to chance alone. So how does this number tell us what that likelihood is? I'll show you that in the next video.